This YouTube video was created by Adam Lockwood and Gavin deGroot. For our Limnology project, Gavin and I decided to research Lake Winnipeg. We made this decision after gaining knowledge about the crucial damage that has been taking place in the recent years in the lake. Studies lately have shown, such as a documentary by David Suzuki called Save My Lake, that problems in the lake are becoming more of a severe problem than we thought, and we're going to outline some of those problems in this project.
We chose Lake Winnipeg because we wanted to find a lake that was similar to the lakes around this area. We also wanted it to be Canadian as it hits closer to home and we might take things a little more seriously. The health of the lake has been deteriorating for years, and it has finally been taken seriously after much criticism has been directed toward the government of Manitoba. To start, we will just show some pictures of some of the evidence of the deteriorating health effects of the lake. After showing some of this evidence, we will go into greater detail on some of the major concerns affecting the lake.
The picture on the right indicates an aerial view of Lake Winnipeg, and it's evident the amount of algae that has built up in the lake. The picture on the left is of a person standing in the water, or what is blue-green algae that's washed up on the shores of Lake Winnipeg.
The photo on the top right shows the extent of the algal blooms and how it is drastically changing the quality of the water through eutrophication. The picture on the bottom left is a scientist taking some samples from the lake, and again you can see the effect that these algal blooms are having on the lake.
This picture shows the evolution of the lake from 5,500 years ago to the mid-period at 2,100 years up to the present time. Decided just to throw this in to show you how much the lake changed, especially the size, because it's gotten a lot bigger. Now we're going to go into some more in-depth detail about the physical characteristics of the lake and problems regarding the lake.
Lake Winnipeg, by area, is the 10th largest body of fresh water in the world, covering an area of 24,514 square kilometers. It is also the third largest hydroelectric reservoir after Lake Superior and Victoria. Lake Winnipeg has two distinct basins: the North Basin, which is 100 kilometers wide, and the South Basin, which is 40 kilometers wide. These basins are separated by the Narrows, which is 2.5 kilometers wide.
Although large in surface area with some deep spots, Lake Winnipeg is generally a shallow lake. It therefore has a low volume of water and typically experiences no thermal stratification. Lake Winnipeg is also subject to wind-driven turbidity when the waves in the lake stir the sediment from the bottom. This is extremely prevalent in the South Basin of Lake Winnipeg.
Lake Winnipeg's watershed is the second largest in Canada, covering an area of 953,250 kilometers squared. It is in 4 provinces and 4 U.S. states. It goes as far west as the Rocky Mountains and as far east to within 150 kilometers of Lake Superior. South it goes into North Dakota, South Dakota, as well as Minnesota. And as far north it goes to the Churchill River drainage basin.
Compared to the lake's surface area, the drainage basin is massive. Lake Winnipeg, in fact, has the largest land drainage to surface area ratio of the Great Lakes in North America. A large drainage area, coupled with the lake's shallowness, results in a relatively short water residence time, which is approximately 3.5 years.
Lake Winnipeg's hydrology is dominated by 4 rivers: the Red River, Saskatchewan River, the Winnipeg River, all drain into the lake, contributing 70% of the water received, while the Nelson River flows out of the lake into Hudson's Bay. The problems with the inflows of these rivers is all the excess fertilizers and nutrients that is being run off all the agricultural land in the prairies, as well as the inflow of human waste and animal waste. And sediment is trapped in this lake as the Nelson River, there's a hydrological development there that traps all the sediment and does not let it flow down the Nelson River. Next, we will show you a video of a simple yet effective way on how to take some of the phosphorus out of the river before it goes into Lake Winnipeg.
Next, we are going to outline some of the problems the lake is facing. We've categorized the problems into chemical, biological, and physical.
Most immediate problems are the algal blooms that cover large areas of the lake in late summer and in the fall. About 8,000 tons of phosphorus enter the lake each year, but only a small fraction of that actually leaves the lake and flows down the Nelson River system. This phosphorus is available to the algae in the lake, and when conditions of warm water and low winds apply, they can form huge blooms easily visible in satellite images. The dominant organisms in these algal blooms are blue-green types of algae, classified scientifically as specialized types of bacteria called cyanobacteria. These organisms can produce highly toxic compounds similar in structure to very small proteins, and so they represent more than an unsightly nuisance. When these algae die, decomposition of them takes oxygen out of the water and can reduce the oxygen so much that fish and other animal life can suffocate. Eutrophication is a worldwide problem in lakes in populated areas. There is good evidence that the root cause behind the problem lies with the amount of the element phosphorus in the lakes.
Reports from the 1930s described blooms of algae in Lake Winnipeg, meaning that the lake produced blooms even before it received the large quantities of phosphorus from its watershed. Satellite pictures of the lake revealed that the size and frequency of blooms have been increasing in recent years. The two main limitations on the production of these algae are the amount of phosphorus and the amount of light. The south basin of the lake is normally quite turbid due to inflows of soil particles, mainly from the Red River. Light cannot penetrate turbid water very deeply, and that limits algal growth there. The north basin has clear water with more penetration of light, and the algae bloom there is more regular and frequent. Manitoba Hydro creates hundreds of millions of dollars in electrical power each year by regulating water flows on the Nelson River, including those from Lake Winnipeg, and passing the water through generating stations. This industry massively changes the flow of the river so that the maximum discharge is in the winter, when the power demand is high, rather than the summer, which is the natural seasonal pattern of maximum discharge. The regulation of water levels in the lake has brought into question the stability of shorelines to erosion. Next, we are going to outline the major changes that Lake Winnipeg has undergone in the last few years.
From 1909 to present, August water temperatures in the south and north basins from Lake Winnipeg have increased. The north basin has increased by 1.9 degrees Celsius, and the south basin has increased in temperature by 1 degree Celsius. Further warming of Lake Winnipeg is expected as air temperatures increase with doubling of global CO2. Warming will affect the entire water column, not just the upper surfaces, in this relatively shallow well-mixed lake. Open water seasons will lengthen as ice cover will shorten. The capacity of Lake Winnipeg water to hold dissolved oxygen will decline as water temperatures increase. The quality of water in Lake Winnipeg has deteriorated during the past 3 decades, principally as a result of excess phosphorus loaded into the lake from watershed sources. Phosphorus is the crucial element controlling the proliferation of blue-green algae that now accumulate as surface scums and contribute to Lake Winnipeg's ranking as the most eutrophic large lake in the world. The more extreme and variable weather events predicted by global climate models may exacerbate the water quality decline in Lake Winnipeg by enhancing nutrient loading. Recent records of the Winnipeg River and Red River summer flows in 2005 carried high phosphorus loads. The following year was a warm and dry year, and the most extensive blue-green blooms ever were observed throughout Lake Winnipeg.
River flow monitoring indicates that river flows to Lake Winnipeg have changed substantially over the last several decades. Relatively less water is now delivered to the North Basin by the Saskatchewan River because of the increased irrigation. Increased precipitation and runoff yields in the Winnipeg and Red River catchment area have resulted in increased flows into the South Basin. Mid-continental summer droughts may become more frequent and intense, with the Prairie River flows into Lake Winnipeg declining even further. Red River flows, predicted to increase by 50%, will have the most important impact on Lake Winnipeg, because in turn the river will deliver more phosphorus to the lake, even though human and animal populations in the basin may not increase in the relevance. Annual evaporative losses, which are equivalent to 2 to 12% of Lake Winnipeg's South Basin volume, are expected to increase with the warming. Due to its relative shallowness and reduced volume, Lake Winnipeg is strongly characterized by its inflowing rivers. Closely tied to this water residence time is the growth and accumulation of planktonic animals, so zooplankton and photoplankton. With sufficient nutrients and sunlight, the longer water stays in the lake, the more algae and zooplankton will accumulate, because they are essentially floating organisms whose distribution is controlled by water currents and water mixing. Natural variability in Lake Winnipeg water residence time is now complicated even further by lake regulation from power production, and this may further be compromised by climate-induced changes in hydrological cycles. We decided to find evidence of acts and projects that have been started by certain people to try and restore Lake Winnipeg. We found a news article that actually shows provincial funding is starting to realize the severity of Lake Winnipeg. The news article is titled "Lake Winnipeg Cleanup Gets $18 million More in Federal Funds." There's a little quote underneath that says, "We're seeing positive results, but more needs to be done." Prime Minister says that the total reaches $40 million. In a little article below, Prime Minister Stephen Harper said today that federal funding will be renewed for cleanup efforts for Manitoba's Lake Winnipeg, body of water he called one of the world's natural wonders, which just shows that even our Prime Minister is realizing how important and how severe the problems in Lake Winnipeg are, and that something needs to be done.
Lake Winnipeg is dying. If we continue to ignore the problems in Lake Winnipeg, they're not just going to go away. Now we know the severity of the deteriorating health, and we can work towards ways of remediating the lake to the health it once had.